Hello, today we're going to look at the effects of skewness on the average, particularly the mean. This is a significant aspect to consider in data analysis related to musculoskeletal injuries and rehabilitation. Skewness refers to the asymmetry in the distribution of data values. There are two types of skewness: positive right skew and negative left skew. Here's how skewness affects the average using examples from musculoskeletal injuries and rehabilitation. So let's start by looking at normal distribution. So in normal distribution, the data values are evenly distributed around the mean with no skewness. So in this case, the mean and median are equal as the data is balanced on both sides. So for example, the distribution of functional scores, so range of motion, after a rehabilitation program for a minor ankle sprain may follow a symmetrical distribution where most patients achieve similar functional outcomes, resulting in the mean and median functional scores being very close or equal. So let's have a look at a positive skew. So this is the right skew. In a positively skewed distribution, the tail on the right side is longer or fatter than the left. Most of the data values are concentrated on the left, with fewer values trailing off to the right. Now this means that the mean is pulled in the direction of the skew, which in this case is to the right. Therefore, the mean will be greater than the median. This is because the mean takes into account all values, including the higher ones in the right tail, which raises its value. Now, for example, consider the distribution of recovery times for patients with a particular type of MSK injury, such as a torn ACL. Most patients might recover within 6 to 9 months, but a few could take much longer due to complications or concurrent conditions. This creates a right skewed distribution where the mean recovery time is higher than the median recovery time, due to influences of the few patients with extended recovery periods. So negative skew. So this is a left skew. In a negatively skewed distribution, the tail on the left side is longer or fatter than the right side. Most of the data values are concentrated on the right, with fewer values trailing off to the left. Now the mean is pulled in the direction of the skew, which in this case is to the left. Therefore, the mean will be less than the median. This happens because the mean includes the lower values in the left tail, which lowers its value. Now, an example, imagine the distribution of pain scores immediately following a standardized rehabilitation protocol for shoulder injuries. Most patients might report moderate to low pain levels, but a few could have very high pain scores due to individual pain tolerance or severity of injury. Now this will create a left skewed distribution where the mean pain score is lower than the median pain score because of the influence of the few lower pain scores. So what are the implications of this within research? So central tendencies measures. In skewed distributions, the median is often a better measure of central tendency than the mean because it's less affected by extreme values. Now, data interpretation. Understanding the effect of the skew on the mean is crucial for accurate data interpretation. In positively skewed distribution, the mean may overestimate the central location, while in negatively skewed distribution, the mean may underestimate it. Data transformation. Sometimes data transformation techniques, for example, log transformation, are used to reduce skewness and make the data more symmetrical, which can then provide a more accurate representation of the central tendency using the mean. So in summary, skewness affects the mean by pulling it towards the direction of the skew, either to the right in the case of positive skew or to the left in the case of negative skew. This can significantly influence the interpretation of the data's central location. And you need to have careful consideration when choosing measures of central tendency and analysing the data, especially in the context of musculoskeletal injuries and rehabilitation outcomes.